In this video, we are going to find real numbers x and y such that the sum equals to 2 and the sum of the fifth powers equals to 82. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. I'm going to solve this system in two ways. The first way is to consider the expanded form of x plus y all to the power 5. By the binomial theorem, you can rewrite that as x to the power 5 plus 5x to the power 4 times y plus 10x cubed y squared plus 10x squared y cubed plus 5xy to the power 4, and finally y to the power 5. As you can see, I rearranged the terms so that for each column it is factorizable. Next, I'm going to try to factorize each column except for the first one, because some of the fifth powers can be replaced by 82 at some point. Whereas for the other two columns, we have 5xy times sum of cubes, which can be further factorized as x plus y times x squared minus xy plus y squared, while for the last column, it's 10x squared y squared times x plus y. Now at this point, I can replace expressions with numbers. For the left, we have 2 to the power 5, and that's 32. The sum of fifth powers is 82 plus 5xy times 2 times x squared minus xy plus y squared, and then plus 10x squared y squared times 2. So simplifying, we have 10xy times x squared minus xy plus y squared plus 20x squared y squared. Then we can simplify that a bit. For the constants, we'll have minus 50 at the left, while for the other expressions, I can take out 10xy as a common factor, and what's left inside the bracket will be x squared minus xy plus y squared plus 2xy. So simplifying, we have this. And so minus 5 equals xy multiplied by x plus y all squared minus xy. So at last, we have quadratic equation about xy. Simplifying, we have xy all squared minus 4xy minus 5 equals 0. And so solving that, we have xy to be either 5 or minus 1. But we can put that together with x plus y equal to 2. We can solve for some quadratic. xy are then roots to either z squared minus 2z plus 5 equals 0, or z squared minus 2z minus 1 equals 0. So solving with the quadratic formula, for the first equation, we have z to be equal to either 2 plus 2 squared minus 20 over 2, and that is 1 plus or minus 2i, or for the second equation, we have z equals 2 plus or minus root of 2 squared plus 4, all divided by 2, and that's 1 plus or minus square root of 2. Now for the first two solutions, they are not real numbers, so I have to reject it. Of course, if we are asking for real or complex solutions, they can be accepted too. So either we have x to be 1 plus root 2 and y be the other, or the other way around. So that's the answer for the system of equations. My second approach would be let x equal to 1 plus a and y equals to 1 minus a. I can do this because the sum is 2. So by doing this, I can degenerate the system into a system of only one variable, an equation of only one variable. And so putting this into the second equation, we have 1 plus a all to the power 5 plus 1 minus a all to the power 5 equals 82. So expanding, we have a to the power 5 plus 5 times a to the power 4 plus 10a cubed plus 10a squared plus 5a plus 1, while for 1 minus a, we have minus a to the power 5 plus 5a to the power 4 minus 10a cubed plus 10a squared minus 5a plus 1, and the sum is 82. So simplifying, we have 10a to the power 4 plus 20a squared minus 80 equals 0. In other words, a to the power 4 plus 2a squared minus 8 equals 0. So a squared is either equal to 2 or minus 4. And that means a is either root 2 or minus root 2 or 2i or minus 2i. And we can see that x and y are either 1 plus root 2, 1 minus root 2, or the other way around. And of course, for the other two possible cases for a, that will give the same non-real solutions as above. So I have to reject because we are looking for real solutions. So this is a final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.